This is section 1.3, part C, measuring spread. The 5-number summary is not the most common numerical description of a distribution. The distinction belongs to the combination of mean to the measure of center and standard deviation to the measure of spread. The standard deviation and its close relative, the variance, measures spread by looking at how far the observations are from the mean. A group of elementary school children were asked how many pets they have. Here are their responses, arranged from the lowest to the highest. First thing we need to do is find the mean number of pets for this group of children. Remember, to find the mean, you're going to add all of the data values together and divide by how many there are in total. So, if we add all the data values together and we divide by the 9 observations, we should see that on average, each child has 5 pets. What does this tell us? So if the children in the group all had the exact same number of pets, each one of those children would have 5 pets. In other words, this is the fair share value. So if all of the pets were fairly distributed amongst the children, each child would get 5. Below is a dot plot of the data with the mean clearly marked. The data value for 1 is 4 units below the mean, so it has a deviation from the mean of -4. We say that its deviation from the mean is -4, but what about the data value for 7? This is 2 units above the mean, so it has a deviation of 2. Below is a table that shows each observation and how far that observation deviates from the mean. So we had an observation of 1 minus the mean of 5, or your x value minus your x bar gives us -4. You had an observation of 3, so your x value minus your mean gives you -2. And if we do those for all of the observations, and we were to add all of those deviations together, you would get a sum of 0. This is because the mean should be the balancing point for all of the data points in the observation. Since the sum of the deviations for the mean will be 0 for any set of data, we need another way to calculate spread around the mean. We need to fix the problem of the positive and negative deviations canceling out. To do this, let's square each deviation. So now if we take each deviation and we square it, so -4 squared gives us a positive 16, -2 squared gives us 4, so on and so forth. If we add all of those squared deviations together, we are now going to get 52. From the sum of these squared deviations, we find that the average squared deviation, which is called the variance. Now to find the variance, you are going to add all the squared deviations, and you are going to divide by 1 less than the number of observations. So we have to do n minus 1. So if we do 52 divided by 8, we're going to get 6.5 as our variance. Because we squared all the deviations, our units are in square pets. That doesn't make any sense to our problem. So we will take the square root to get back to the correct units, which is just pets. So the resulting value is called the standard deviation. The standard deviation is equal to the average square deviation. So we would take the square root of 6.5 and we would get 2.55. Now average is in quotes because if it was the true average, we would divide by the total number of observations. But since we divide by the number -1, it is not the actual true average. This 2.55 is roughly the average distance of all the values of the data set from the mean. So this means if we take all of the data values and we were to distribute the distance each one of those points are away from the mean evenly, each of them would be 2.55 units away from that mean. The standard deviation, which we call S sub x, measures the average distance of the observations from their mean. It is calculated by finding the average of the squared distances and then taking the square root. This average squared distance is called the variance. In symbols, we write variance as s sub x squared. And we know that we find that with this given formula. So s of x squared is equal to the sum of all the x values minus x bar, or minus the mean. You square those, and then you add them together, and then you're going to divide by n minus 1. To find the standard deviation, or s of x, you take the square root of the sum of all deviations squared divided by n minus 1. So, how do you find the standard deviation? First, you're going to find the distance of each observation from the mean. To do this, remember, you're going to do the observation minus the mean. Then you are going to you're going to square each one of those differences. You will average that by dividing by n minus 1, and then you will take the square root to get the standard deviation. Many calculators report 2 standard deviations, giving you a choice of dividing by n or dividing by n minus 1. The standard deviation for the entire population, sigma sub x, is found by dividing by n, while the standard deviation for a sample of the population is s sub x, is found by dividing by n minus 1. The distinction should be made that you will always use s sub x if it's a sample of the population. You will only divide by n if you have the data for the entire population set. So you first must decide if you are examining an entire population or if you are examining a sample of that population. One way to tell is if you look at the mean. The mean of the entire population is denoted as sigma, while the mean of the sample of a population is denoted as s sub x. More important than the details of calculating s of x are the properties that determine the usefulness of the standard deviation. S of x measures the spread about the mean and should be used only when the mean is chosen as the measure of center. Now, if you remember previously, we discussed that you should only use the mean as long as the data is roughly symmetric. So standard deviation should only also be used if the distribution is roughly symmetric. If you were talking about the median, you should use the IQR instead. Standard deviation is always greater or equal to 0. A standard deviation of 0 only occurs if there is no variability. So this means that every single value in the data set would have to be exactly the same. Otherwise, your standard deviation will always be greater than 0. It has to be a positive number because it is a square root of a value, and you cannot get a negative answer when taking the square root of a real rational number. The standard deviation has the same units of measurement as the original observation. So if we're talking about the metabolic rate in calories, both the mean and standard deviation will also be in calories. This is also one reason we prefer the standard deviation to the variance, which would be the square calories. Now, good news, if you have a large set of data, you are not going to want to find the standard deviation by hand, so the calculator can find standard deviation for you. Let's look back at that example about the North Carolina drivers and how long they have to travel to get to work. To do this, the first thing you're going to do is you're going to input all your data into list 1. Then you can press the stat button, go over to calculate. You're going to choose option 1, which is 1 variable statistics. You're going to press enter. Then you will press second 1, which will select list 1, and hit enter. If you arrow down, you will see the rest of the 1 variable statistics for North Carolina. So this can actually show you the minimum, the Q1, median, Q3, maximum. It can tell you the mean and the standard deviation. So if you look, it tells us we have a mean of 22.46 repeating. The sum of the x values is 337. Our standard deviation, Sx, is your standard deviation of a sample, is 15.23, And the sigma sub x is the standard deviation of a population, which is 14.7. Now, we know that we took a sample of 15 drivers, so you should use the S of x. You only use the sigma sub x if you have the entire population in your list. It tells us that we know there are 15 data points in this set. We can also see the minimum value, Q1, median, Q3, and maximum values while using this feature. Now, how do you choose which measure of center and spread? The median and IQR are usually better than the mean and standard deviation for describing skewed distributions or distributions that have strong outliers. You should use the mean and standard deviation only for reasonably symmetric distributions that do not have outliers. You need to be cautious. Remember that a graph gives the best overall picture of a distribution. Numerical measures of center and spread report specific facts about a distribution, but they do not describe its entire shape. Numerical summaries do not highlight the presence of multiple peaks or clusters. Always plot your data. For their final project, a group of AP Statistics students investigated their belief that females text more than males. They asked a random sample of students from their school to record the number of text messages sent and received over a 2-day period. Here is their data. So we have data for all the male students and data for all the female students. What conclusion should the students draw? Give appropriate evidence to support your answer. This is going to be a 4-step problem. So remember, when we do our 4-step problems, you need to state, plan, do, and then conclude. So your state is always determining what question are you trying to answer. So for our state, do the data can give convincing evidence that females text more than males. Now we need to come up with a plan. So we will begin by making side-by-side box plots. Then we will calculate one variable statistics. Finally, we will compare shape, center, spread, and outliers for the 2 distributions. So you would actually need to write out all this information on your plan, telling whoever is grading your information what you plan to do and how you plan to solve this problem. Now, when you get to the do, you are going to use your one variable statistic. So if you find this on your calculator, you need to make sure you label this very well on your paper. You can make a table of all this information, and then you can also make a box plot comparing the males and the females. Because both distributions are strongly skewed, we know that we should use the median and IQR when we're discussing the center and spread instead of using the mean and standard deviation. So still in this do, we are going to compare the shape, center, spread, and outliers. So if we take a look at these distributions on the graph, both distributions are heavily skewed to the right. So since they're heavily skewed to the right, we're going to compare their IQRs for their spread. There is more variability in texting among females than males, since the IQR is 157 for females, while the IQR is only 77 for males. Remember, to find that IQR, you're going to do Q3 minus Q1. Our center tells us that on average, females text more than males because the median number of texts for females is 107, and that's about 4 times higher than the median value for males, which is 28. We know that there are 2 outliers in the male distribution, students who reported 213 and 214 text messages in 2 days, and there are no females who are considered outliers. So based on this information, we now have to reach a conclusion. And we can conclude that the data from the survey project give very strong evidence to support the students' belief that females text more than males. Females sent and received a median of 107 texts over the 2-day period, which exceeds the number of text messages reported by over 75%, or the Q3 value of the males. When you go to take your AP exam, use statistical terms carefully and correctly on the AP. Don't say mean if you really mean median. Range is a single number, so are Q1, Q3, and IQR. Avoid colloquial use of the language, like the outlier skews the mean. Skewed is a shape. If you misuse a term, expect to lose some credit. So let's check our understanding. The height in inches of 5 starters of the basketball team are given. Find and interpret the mean, and you must show your work. So to find the mean, remember you are going to add all the data values together, and then you will divide by the total number of observations. And this will give you 75 inches. So this means if all 5 starters on the basketball team were the same height, all of them would be 75 inches tall. Or if we took the height of all the players and evenly distribute them among the players, they would each be 75 inches. Make a table that shows for each value its deviation from the mean, its square deviation from the mean. So to set this table up, you would make a list of the observations. To find the deviations, remember it's always your x sub I, your observation value, minus your mean or your x bar. So we would do 67 minus 75, which gives us negative 8. 72 minus 75 gives you negative 3, and so on. To find the squared deviations, you would just take those deviations and square them. Remember, anytime you square a negative number, it becomes positive. Show how to calculate the variance and standard deviation from the values in your table. Remember that the total squared deviation is 156. So to find the variance, or S sub x squared, you take the total squared deviation and you divide it by n minus 1. Now we know that there were 5 observations, so 5 minus 1 is going to give us 4. And if we divide that out, we're going to get 39 square inches. To find the standard deviation, you're going to take your variance and take the square root. And the square root of 39 is going to give us 6.24 inches, which means on average, each basketball player has a height of 6.24 inches away from the mean height of all the players together. Interpret the mean and standard deviation in the setting. So the players' heights vary about 6.24 inches from the mean height of 75 inches on average.